In this tutorial, I'm going to discuss formal language on Automata Lesson 2, that's Chomsky classification of grammar. In the earlier tutorial, I discussed what is sentence, what is grammar, what is language, and how they are made. In this tutorial, I'm going to talk about Chomsky classification of grammar, how Chomsky classified grammar. Well, Chomsky classified the grammar into four categories depending on production. The four categories are type 0 grammar, type 1 grammar, type 2 grammar, and type 3 grammar. Now, type 1 grammar is also known as context sensitive grammar. What is context and how it is sensitive, I shall discuss this later. But for the timing, just know this information that type 1 grammar is also known as context sensitive grammar. Type 2 grammar is also known as context free grammar, and type 3 grammar is known as regular grammar. Okay, now another bit of information is there is a downward compatibility from type 0 grammar to type 3 grammar. As you can see here, as you can see is written here, this is downward compatible means uh, I shall explain you in the next part, that is, well, let's come here. All grammar are type 0 grammar. Okay, so every single grammar is of type 0 grammar, irrespective of whatever type it may be, it is always of type 0. Okay, now let's take a look at this picture. Suppose this is a Venn diagram. I suppose you all know what a Venn diagram is. This is a Venn diagram. Okay, now let's assume this outer circle is this circle, the outer one, the topmost. This is the total grammar. Let's assume this is a total grammar, and it is of type 0 grammar. Why? Because all grammar are type 0 grammar. So total means this big circle, the entire grammar, total grammar is of type 0 grammar. Within type 0, some are type 1 grammar. As you can see with this circle, some are type 1 grammar. Within type 0, some are type 1 grammar. And within type 1 grammar, some are type 2 grammar, as you can see here, and so on. Within type 2 grammar, some are type 3 grammar. So type 3 grammar is also type 2 grammar, is also type 1 grammar, and is also type 0 grammar. Similarly, type 1 grammar is also type 0 grammar, and type 2 grammar is also type 1 grammar and type 0 grammar, as written here. Within type 0, some are type 1. Within type 1, some are type 2. Within type 2, some are type 3. Because of this nature of grammar um, and Chomsky classification, that's why it's written here downward compatibility, because type 2 grammar is also type 0 grammar, so it's downward compatible. Okay, now let's move on to the next page. Now moving on, in formal language theory, any production can be represented as phi a psi, this arrow, then phi alpha psi. I assume you remember what production rules are. I discussed it in the previous tutorial. The grammar has four tuples and variable, terminal, production, and starting symbol. Well, this is a production rule we are talking about. Let me repeat once more. In formal language theory, any production can be represented as in this format. This is the format of representation of production rule. It is phi a psi tends to phi alpha psi. Now, what is the meaning of these variables? A means a variable, phi means the left context, shy, which means the right context, and phi alpha shy, which means replacement string. Okay, so this right hand side, it means replacement string. Phi is a left context because it's the left of variable a, and shy is the right context because shy is the right of variable a. In the previous picture, I stated here type 1 grammar is context sensitive grammar. So now you know what context means. I shall discuss why it's called context sensitive grammar. Okay, let's take an example. S tends to A S B, small a capital S small b. Now if you remember, I explained variables are capital letters and terminals are small letters. Variables are capital letters and terminals are small letters. This is the convention used. Now let's find out what's the value of alpha. Okay, so this is the general form phi a psi, which tends to phi alpha psi. Okay, now let's put this equation in this place. Let's put this s, let's compare this s with the left hand side. Phi a psi and nothing s, again nothing. I stated just now that a is a variable and variable is capital letters, and this has capital letter, and phi and psi, these are terminals actually, so they will be always small letters, so there are no small letters. That's why we can assume that it's blank before s, this blank after s. Now what is blank? Blank means null, and in the previous video I explained that null means lambda. So it's lambda s lambda, which when compared with the general form phi a psi, which equates phi is lambda, psi is also lambda, and s is a. Okay, so a means s, phi means lambda, psi means lambda, but this should have been a tends to s and not the other way around. Okay, and so right hand side, the general equation is phi alpha psi. Okay, so phi alpha psi is a is b. Okay, now we know that psi and phi, they are both lambda, so lambda alpha lambda equal to a is b. Lambda is nothing, lambda is nothing, so nothing in the middle, whatever it is, it will be alpha, so alpha is a is b. So this is done. Okay, let's take another example. Small a capital A, which tends to a. Comparing the general form phi a psi, which tends to phi alpha psi, and the left hand side that's given here is small a capital A. So, and we know that a belongs to a set of variables, so a must be capital letter. So we can assume that this a is equal to this a, so a is a and phi is the small a, and psi is nothing, so it's lambda. And replacing the value of phi and psi in the right hand side, we get a and nothing, that's a lambda. So a alpha equal to a lambda. This phi is a, so I'm replacing this a. Alpha I don't know how to find out, and this is lambda, so alpha is equal to lambda, as simple as that. Now let's move on to type 0 grammar. Any production is type 0 production. Okay, any production is type 0 production. We have discussed this earlier. Here all grammar are type 0 grammar. In the same logic, any production is type 0 production. A grammar is called type 0 grammar if it's made of type 0 production. Grammar is called type 0 grammar if it is made of type 0 production. If all the productions are of type 0, then the grammar becomes of type 0. Now, a language made of type 0 grammar is known as type 0 language. If the language is made of grammar and all the grammar are of type 0, then it's called type 0 language. It's not necessary that all the grammar should be of type 0, but I shall discuss that, you'll understand then. For example, suppose the first production is of type 0, the second is of type 1, and third is of type 2. Then the net language is of type 0. That's because type 2 is also type 1 and type 1 is type 0. So the bigger one means the one which encompasses all the other is type 0. So the language is type 0 language. And another example, suppose first production is type 1, second is type 1, and third is type 2. We know that type 2 is also type 1, so the net type that encompasses all of them is type 1. So this language is type 1. Now moving on to the next one, type 1 language, sorry, type 1 grammar. If alpha of means of the form phi a psi, which tends to phi alpha psi, is not equal to lambda. If alpha is not equal to lambda, if this alpha is not equal to lambda, now lambda is null, so alpha is not null, then it's type 1 grammar. It's type 1 grammar if its production set is of type 1 production, also called context sensitive grammar. Language from type 1 grammar is type 1 language. Okay, this is the same argument as this one which you have stated here. So so the important thing to note here is the condition which will satisfy grammar to be type 1 grammar, and the condition means alpha should not be equal to lambda, and this should not be null. Well, there is only one exception to this rule. The exception is if phi and psi, if both are lambda and alpha is lambda, then it's a type 1. So it's summarized here: phi is lambda, psi is lambda, and alpha is lambda. Means the entire thing is lambda, is null, then it's type 1. Moving on to the next page. Okay, okay, now let's move to type 2. The production of the form a tends to x, where a belongs to a set of variables and x belongs to the set of variables union terminal is star. I have discussed the meaning of star. Now this means the set V union T star is a set containing lambda, means nothing, or combination of variables, or combination of terminals, or combination of variables and terminals, means all possible combination of set of variables and terminals is possible, including lambda or null. This is a condition of type 2. A should be set of variables and x. Now you must be confused what x means. Well, x is nothing but the lambda. We are talking of lambda. Lambda should belong to set of variables union terminals. It's star. Now a grammar is a type 2 grammar if its production set contains a called type 2 production. This is the same one saying language is generated from type 2 grammar is called type 2 language. As simple as that, nothing here, nothing much. Now type 3 grammar. What is type 3 grammar? Type 3 grammars condition is A tends to small a capital B or A tends to B. If these conditions satisfy, then it's type 3 grammar. Obviously, for type 3 grammar to be satisfied, it must satisfy type 2 grammar as well, and type 1 and type 0. Now, there are some rules. What is A and B? Capital A and capital B. Capital A and capital B is set of variables. They belong to set of variables, and small a and small b belong to set of terminals. So A, B belongs to set of variables, and small b belong to set of terminals. If this condition satisfies, then it's a type 3 grammar. So A can be only a terminal, or I'm sorry, A can be, A must be A, and A must belong to the variables, and this is alpha can be a terminal and variable, or only a terminal. Then it's type 3 grammar. Type 3 grammar is also known as regular grammar or context free grammar. Now let's move on to derivation. What is derivation? The process by which we can get the sentence starting from the start symbol repeatedly, by repeatedly replacing the production's left hand side by its corresponding right hand side is known as derivation. Example, the starting symbol S is B, C and small d, and we have to reach this sentence small a e d. Now, as we know, a final sentence can only have terminals, it cannot have variables. Okay, this is starting symbol. Now, some rules are given. Capital B is equal to small a capital B or small a. C can be small a capital D. D can be small a capital D or E. This pipe symbol means or. Now, derivation is from this starting symbol to reach this sentence. How we can derive this sentence from this starting symbol? Well, this can be achieved. Well, there is no one method of reaching the sentence from the starting symbol. There are many methods, and one of the possible methods I am discussing here. This is starting symbol BCD, and I am replacing B with AA. So AA here, then CD. A remains as it is, D remains as it is, and I am replacing C now. And I am replacing C with AD, so it becomes A capital D small d. Now replacing capital D with small a capital D, it's small a capital D or E. I am replacing with small a capital D, so it becomes A capital D and small d. Now I am replacing capital D with small e. I can do this because there is a type symbol means or it can be small a capital D or it can be E. So I'm replacing it with E now. So it becomes A small d and small d. So as we can see, we have reached this sentence from this starting symbol following these production rules. Well, there are two ways how we can solve this type of problems. There is leftmost derivation and rightmost derivation. What is leftmost derivation? Leftmost derivation means deriving the final sentence from the starting symbol from left to right, from left hand side to right hand side. We solve each of the variables from left hand side to the right hand side. And rightmost derivation means the reverse. We solve the starting symbol to obtain the final sentence from right hand side to the left hand side. Means we would solve D first, but small d is already terminal. We need to solve it. Then we have to solve C, get the variables and terminal, then keep solving, and we solve from right hand side to the left hand side. So this is all for this lecture, and all of these images notes I'm going to make it available In the description below, there will be a GitHub page, and you can download all of them in this in a zip format, and you can play with them, you can study them, and that's it for this video. Thank you. If you like this video, do it like and do share with your friends. Thank you.